Hey guys, and welcome to the lesson. Today we'll be looking at Amazon API Gateway. API Gateway is a fully managed service that allows you to create serverless APIs. Create, maintain, and secure APIs at any scale. This pretty well sums up what API Gateway does. So with this service, Amazon takes care of everything behind the scenes that needs to happen in order to handle hundreds of thousands of concurrent requests and also manage security and scaling, taking full advantage of Amazon's global network and computing resources. As with many of the serverless products, price is a big advantage here, as you're only paying for the amount of requests made and the amount of data transferred in and out of the gateway. So your costs scale along with the usage of your API. In this lesson, we'll be using API Gateway to create a simple REST API to interact with our Lambda functions to get and set user data. So API Gateway will call our Lambda functions, which will in turn get and set data in the database. Now this builds on top of the previous lesson where we set up 2 Lambda functions and a users table in DynamoDB. So if you haven't seen that one yet, you may want to pause this video and complete that tutorial first. Link in the description below. However, if you're just interested in seeing how to wire up API Gateway with Lambda, you can definitely still get a lot of this tutorial without completing the previous one. Alright guys, let's get coding. Alright, let's go ahead and log into the AWS console and go ahead and type in API Gateway into the search box. That should pop right up, and that link will take us to the API Gateway landing page. Now, if you're here for the first time, you may see some sort of pop-up dialog telling you about the example REST API that's been set up for you. Feel free to go ahead and dismiss that and click right on the Create API button. Okay, we can leave the first 2 defaults selected. We are creating a REST API, and we are creating a new API. So let's go down to Settings and give our API a name, and I'm going to call it Users API, and I'll enter in a quick description. Okay, now we have a couple of options for endpoint type. With regional, this is going to deploy your REST API to the region that you're currently working in. So in my case, it's US West 2, Oregon. Now, if you have a lot of users from around the world, you may want to consider selecting Edge Optimized. Now, with this one selected, you're going to be able to take advantage of AWS's CloudFront Content Delivery Network, which means that your REST API is going to be cached at various edge locations in different regions around the world, which will give a significant performance boost to users that aren't necessarily close to you or close to your region accessing your REST API. So I'm going to go ahead and use Edge Optimized here and click on Create API. Okay, now before we start to architect out our REST API, we want to think about what it's going to look like. So what are we doing here? We are setting and getting user data in our database. So a typical REST API for that may look like domain/users/ID, where ID is going to be a path parameter because it's a variable. You know, each user will have a different ID. So what we can do is go ahead and click on Actions and create resource. Now each resource you can think of as being a part of the path of your REST API endpoint. So we'll give this a name. Let's see, let's do user. And you can see that it automatically populates my resource path with the lowercase version of the resource name that I've provided. Okay, so that looks good. Enable API Gateway cores. Now, I don't think I'm going to do that right now, but this may be useful if, for example, your REST API endpoint is of a different domain than where your client is going to be accessing your REST API from. In this case, it's the same domain, so I'm not going to worry about that. I'm just going to click on Create Resource. Okay, so far, here's what our endpoint looks like, /user. Now, the next thing I want to do is have the /ID, where ID is going to be a variable path parameter. So go ahead and click on Actions. Let's click on Create Resource again. We'll call this one ID. And in the resource path, now if we want this to be a variable, what we can do is surround this, the resource path name with curly braces, like so. All right, and go ahead and click on Create Resource. All right, so user/ID, looking good so far. I think the next thing we want to tackle here is going to be our get functionality. So from the actions dropdown, let's go ahead and select create method this time. And let's choose get from the dropdown. And click on the arrow. Okay, get setup. Now integration type. Let's go ahead and leave Lambda function selected. Obviously we're integrating with our Lambda function. Next option is use Lambda proxy integration. Let's go ahead and select that. Now what this allows us to do is access all of our request parameters and request body from the event argument of our Lambda function. So we'll definitely be needing that. So ensure that's selected. Lambda region, go ahead and make sure that your region is selected. And Lambda function, let's go ahead and select our get user data function. Okay, and let's use the default timeout. Go ahead and save. Add permission to Lambda function. So this is just letting us know that we're about to give API Gateway permission to invoke these functions. Let's go ahead and click OK. Okay, so we are now inside of the get method execution control panel, and I'm just going to make my screen a little bit bigger here. All right, now let's go ahead and click on method request. There are a few options here we can take a look at. Okay, under settings, first of all, authorization, it's defaulted to none. Let's go ahead and edit that and change it to AWS IAM. Now with this option selected, basically this allows us to use IAM roles to create fine-grained permissions regarding who can update, who can change our REST API, and also who can call the API. So let's save that by clicking on the check mark here. Request validator. This allows us to validate different aspects of our HTTP request. You can choose just body, you can choose sort of all the parameters or different combinations here. We're going to choose the middle option that'll allow us to validate everything basically. So save that. API key required, let's leave that to false. Okay, and we can take a look at some of these options here. Request paths, ID, that looks good. We don't have any query string parameters, so we don't need to look in there. Let's check out the HTTP request headers. I'll go ahead and add a header just for good practice here. I like to add the content type header, which will be application JSON. Save that. Okay, and we have no request body, and we don't need to take a look at SDK settings, so we can leave that alone for now. All right, so let's go back to method execution, and we can go ahead and test out our first get method. So click on the little lightning bolt here under test. Okay, now if you remember to the last lesson, we had a couple of users in our test database. So let's enter 67890. That is the ID of one of them. Okay, and for headers, go ahead and add our content type, colon, and give it a value of application JSON. Okay, we can leave everything else as is, and let's go ahead and click on the test button. Okay, so here's our response from Lambda. It's good that we are getting a response. It's bad that we got a 502 response. So let's see what's going on here. Internal server error. Okay, and as you can see, we've got some log output over here from Lambda. And if we scroll towards the bottom, here we go. Execution failed due to configuration error. Malformed Lambda proxy response. So what's going on here is, if you remember back to the Lambda function that we created in the last tutorial, our response was basically just a console log. So the thing is with API Gateway, it's expecting a properly formatted or a specifically formatted response object. Okay, so I'm going to go ahead and jump on over to Visual Code here. And as you can see, we're simply console logging the data that comes back. So we don't have a response of any kind. So the next task for us is going to be to go ahead and refactor our Lambda function so that we're returning a properly formatted response so that API Gateway can deal with it. All right, guys, so in refactoring this Lambda function, what we want to do is basically return a response object that contains the status code, any response headers, as well as the response body, which will be the user object coming back from DynamoDB. So let's start to set up some of these properties, and then we can add them to the response object. All right, let's do a response body and initialize that with an empty string. And let's do a status code and initialize that to 0. All right. Now, if you recall earlier, I mentioned that we can access some of the request parameters and the request body via the event object. So what we need to do is get the user ID and replace this hard-coded ID with the actual user ID passed into the Lambda. So we can use destructuring syntax to extract the ID from the event. And we want to use a property called path parameters, like that. There we go. Okay, so now we can replace this hard-coded ID with ID from above. All right, and we can get rid of our console log here. And now we want to set the response body to the actual response. So let's do response body equals data.item. Now data.item, that is just how DynamoDB formats its responses, and so this item will actually contain the user data. All right. Now also we want to go ahead and stringify this before we return it. So .json.stringify. All right, now let's go ahead and get rid of our catch console log. And we can set the response body to an error message in the case of an error. So let's do response body equals unable to get user data. Okay. And we'll set the status code to, let's do a 403 for our error. Oh, and of course we also need a response code for our success case. We'll set this one equal to 200. All right, good. Now let's go ahead and construct our actual response object and add the properties that we just created to it. So let's do a const response. Okay, set that to an object. And let's see, we'll have a status code property. Oops. Status code. Equal to status code. All right. Headers. Now under headers, you just have an object and you can have a comma separated list of headers. So in this case, let's just do kind of a test header. My header equals test. All right, that'll do for now. All right, we'll have a body, which will be equal to the response body. Okay. And I think that's all we need. That looks pretty good. So finally, let's go ahead and return. All right, much better. So now we're actually returning a response from our Lambda function. What we can do now is update our existing getUserData Lambda function with this new version, and then rerun our test on our API Gateway. So let's go ahead and select all here, copy that to your clipboard, and now we need to go over to AWS Lambda and copy paste this code into our Lambda function. So let's see, click on Services, and you should see Lambda over to the left if you've done this recently. Otherwise, just go ahead and type it into the search box. Navigate over to Lambda, and let's click on Get User Data. Okay, now just scroll down a bit, and let's go ahead and copy, delete, and then copy paste our new code here. All right, and go ahead and save that. All right, cool. Now our Lambda function is updated, so let's go back on over to API Gateway and test out our code. So click on API Gateway. All right, click on the Users API. Click on the Get method. Click on Test. And let's enter in our request parameters again. So the user ID was 67890. And let's add our content type header again. Content type : application JSON. All right, now scroll down a bit and go ahead and click on the test button. All right, looking good. Now here is our user data, Bob Johnson 67890. So as you can see with that reformatted response, everything's working correctly. API Gateway recognizes that response, and looks like our get method is working great. All right, so next up, we need to go ahead and create another method for our put functionality, where we want to put the user data into DynamoDB via our Lambda function. It'll look very similar to this one. The major difference will be that we're actually now dealing with a request body. So we'll have our user object passed in to the Lambda function via that request body. Okay, so for adding a user into the system, what we want to do is create a post method. So we won't be needing the ID path parameter anymore because we'll be sending all of our data on through the request body. So what I want to do is click on user and create our new method from here. So under the actions dropdown, let's go ahead and select create method. And let's select post and save that. Okay, we'll leave many of these options the same way we did with the get method. So Lambda function, that's good. Use Lambda proxy integration. Let's go ahead and check that. And leave our region the same. And for Lambda function, let's do put user data. Okay, make sure our timeout checkbox is checked, and let's save that. Okay. All right, now let's click into our method request. So for authorization, we can make the same selection as before, AWS IAM, save that. Request validator, let's go ahead and just validate the body on this one. So save that. Leave everything else the same. Okay, and let's expand HTTP request headers, and let's just add our content type header. Just the same as before. All right, and save that. All right, now let's click on the request body section. Okay, so again, the request body is where we'll be passing in our ID, our first name, and our last name. Now, API Gateway has this concept of models. So a model is nothing more than a schema for an object. So in order to have some predictability when we're coding our Lambda function and knowing what parameters we can expect to be passed in, we can set up a model. So let's go ahead and click on Models from the left-hand menu. And let's go ahead and click on Create. All right, we'll give this model a name. We'll call it User, and content type will be Application JSON. All right, we can leave the model description blank for now. All right, so our model needs to follow a specific syntax in accordance with the JSON schema draft 4. So what I want to do is go on over to the API Gateway documentation and look for an example that we can copy, paste, and modify from there. So I've gone ahead and bookmarked the link to the API Gateway documentation. I'll add this to the description so you guys can just click on it there for easy reference. So I want to scroll down a little bit here, and let's go ahead and copy paste this example into our API Gateway interface. Okay, so what we can do is nuke everything under properties here. All right, oops, deleted one too many curly braces there. All right, we'll add our new properties in here. But first, let's go ahead and modify the title. So this is a grocery store input model. Let's change this to user model. All right, type object, that's good. And properties, let's start to add our properties. We've got ID. Now the value for the properties needs to be an object that defines the type. So type, and we'll set this to string. All right. Now we're going to copy this for our next two properties. So let's go ahead and just copy this line, we'll add a comma, and let's add it two more times. Whoops. I'm getting mixed up with my Mac keyboard shortcuts here. There we go. All right, so the other two properties for our user were first name and last name. All right, that looks good. So let's go ahead and click on Create Model. All right, now we can go ahead and add our model to our request body. So let's go back to our users API. All right, click on Post, click on Method Request. All right, and hopefully our selections have persisted here. Yep, everything looks good. So let's go back to Request Body. Now we should be able to click on Add Model and Application JSON. And let's select our user model from the dropdown. and save. All right, so our put request is looking good. Now, we know if we tested this right off the bat, it would fail because we still haven't refactored our Lambda function to return a properly formatted response. So as our next task, let's go ahead and refactor our Lambda function. All right, I'm going to jump back over to my code editor here. Now, I'm going to leave my get user data Lambda source code open because we're going to end up copying and pasting a lot of this code. A lot of, 90% of this is going to be reusable. So let's go ahead and open up our put user data index.json file. All right, now we're going to go back and forth here a bit and just copy and paste some of this boilerplate code. So let's start with our response body and status code from the get method. Let's copy that, and let's go ahead and paste that into our put user data. Okay, now one thing that is going to be different is the way that we extract our properties from the request. Since we're dealing with a post now where most of the data, or all of the data, is coming through the request body, this is going to look a little bit different. So let's do constant, and we'll still use our destructuring syntax to grab the ID, first name, and last name. Okay, equal event. And this time it's going to come from the body parameter. All right. Now one thing we'll need to do here is json.parse. Okay. So that will go ahead and convert this object into JavaScript JSON so that we can work with it later. Okay. Now we can go ahead and replace all of these hard-coded values with our ID, first name, and last name. Okay, that looks good so far. All right, let's go back over to our get function. And let's see. Let's go ahead and copy and paste our success case code here from the try back over to put. And let's just copy that over our console log. Okay, we can change this to data because we're not returning an item in this case. We're just returning, it'll probably be an empty object actually. And we'll update our status code from 200 to 201 for create item. All right, let's go back over to get, and let's copy our error handling code. Okay, back over to put, and again, we'll just copy paste this over our console log statement. And I'll just change the wording a little bit here to make more sense. Unable to put user data. Okay, now the last thing we want to copy over from get is going to be our actual response object and our return statement. So copy that, and we can keep everything as is, and just go ahead and paste it here below the try catch. All right, I think that looks good. So let's go ahead and select all, copy that to your clipboard. Now we need to head back over to Lambda and update our put function. All right, so what I'm going to do is expand the services dropdown and just right-click, open a new tab on the Lambda. Okay, and click on Put User Data. Okay, let's just scroll down a bit, and we can just nuke all of this old code and paste our new code in there. All right, and save that. All right, now let's head back on over to API Gateway and test out this code. Okay, so let's see, post, we need to just click on your post method there. Oh, I'm sorry, click on the method execution and click on the test lightning bolt, and let's set up a little test case here. So I'm not going to worry about the headers since we're not validating that. Let's just go right for our request body. Okay. So I'm going to set the ID just to, let's see, 54321, comma. Let's do a first name. Let's set that to Larry. And let's do a last name. Oops, last name, colon. Let's say David, Larry David. All right, let's go ahead and run this test. Okay, that looks good so far. Status 201, the response body, just an empty object, which is what we expected. And don't see anything off in the logs. Everything looks good to me. So what we can do now is head on over to DynamoDB and just ensure that our newly created user is in fact in the system. So let's again expand the services, and you should have DynamoDB off to the left-hand menu. But if not, just go ahead and type it in the search bar and it should pop up. So again, I'm going to open this up in a new tab. And let's click on Tables. Let's click on our Users table. Let's click on the Items tab. And there we go. There's our Larry David user. So that's good news. That means our Lambda functions are working, our API Gateway front door is working, and everything is working together. All right, guys. Well, that concludes today's tutorial. So hope you found it useful. Hope you learned something. And if you find these tutorials useful in general, don't forget to like and subscribe. And I'll see you guys in the next video. All right. Have a great day, guys. Bye.